Welcome to week 4, folks. We're past the halfway point and then some. I'm Tim Hanna, WB9NJS. I will be one of the 2 presenters this evening. Mike Carroll from Fort Bragg will be doing the other segment. Again, want to thank everybody who helped make this happen, a bunch of people and organizations behind it. So thanks to all of our sponsors. Here is the summary of the topics. We are in session 4. We've got 2 of them on the agenda tonight. I will be leading off, as I said, with section T2, which is operating procedures. Mike Carroll will follow up with T4, amateur radio practices. Kind of some overlap here. Up until now, we've been doing a lot of theoretical stuff, learning formulas and the like. This is more hands-on. Both of these segments are really the nuts and bolts, the hands-on of what do you do when you have a license? How do you talk to somebody on the air? How do you hook up your equipment? How do you actually make this work and communicate? So that's what we've got in store tonight. Covered in my section, the T2, which is operating procedures. Use of FM and repeaters. How to make a contact, some of the basic protocols, and also emergency operations out of the ordinary in amateur radio. But before we do that, before we dive in there, we're going to backtrack a little bit, do a quick review of previous sections, T7, T8, T0. That covers station equipment, signals and modulations, and safety. So, first question, which of the following describes combining speech with an RF carrier signal? Impedance matching, oscillation, modulation, low-pass filtering. Anytime you add information to a signal, you are modulating that signal. So the answer is C, modulation. What device increases the transmitted output power from a transceiver? An RF power amplifier, a voltage divider, impedance network, or the right answer in that case is A, an RF power amplifier. Okay, next question. Which of the following measurements are commonly made using a multimeter? You can measure voltage and resistance, signal and noise, impedance and reactance, all these choices. Nope. A multimeter, as big as the name sounds, is fairly simple. It'll let you measure voltage and resistance and typically current as well. What is a symptom of RF feedback in a transmitter or transceiver? Well, if somebody tells you you have a garbled or distorted, unintelligible voice transmissions, you may be getting some RF feedback back into your transmitter or transceiver. Which of the following types of emission has the narrowest bandwidth? Is it FM voice, single sideband voice, CW, or slow scan TV? Well, the very lowest of anything we talked about is CW, or continuous wave, also known as Morse code, about 170 hertz, a fairly narrow signal versus FM voice at 10 to 15 kilohertz. Oh, hey, if you want to mount signals off satellites orbiting the Earth, you're going to want to use a satellite tracking program. So which of the following are inputs to a satellite tracking program? The transmitted power, Keplerian elements, last observed time of 0 Doppler shift, all of the above. Well, no, only one is correct, and those are the Keplerian elements. Kepler came up with a way to describe orbits, and the Keplerian elements are what a satellite program uses to determine. Oops, sorry. Okay. Continuing on into the digital world here, what is an amateur radio station that connects other amateur stations to the internet? Well, you connect other stations to the internet via a gateway, not a repeater, beacon, or digipeater, but a gateway is how you get to the internet, right through the gate. What is FT8, Fox Tango 8? A wideband FM voice mode, a digital mode capable of low signal to noise operation, 8-channel multiplex, or digital slow scan? Well, FT8 is a very, very popular digital mode, and it's capable of low signal to noise operation. What that means is you can actually get a message through when you can barely hear the signal from the other end. Where should a fuse or circuit breaker be installed in a 120 volt AC power circuit? If you're building your own equipment, you better know that you want to hook it connected in series with the hot conductor only. The hot conductor is the black wire in that line cord. So that would be in hot conductor only. Okay, I think this is a simple one, but maybe not. Why should you avoid attaching an antenna to a utility pole? Well, there's a couple of reasons there, but the one that makes the most sense is that antenna could contact high voltage power lines, and that is just flat out disastrous. You do not want that to happen. You don't want your antenna anywhere near utility lines, particularly high voltage lines. Regarding RF exposure to the human body, at which of the following frequencies does a maximum permissible exposure have the lowest value? So is it 3.5 megahertz, 80 meters? Is it 440 megahertz, 50 megahertz, or 1296? Well, it just so happens the human body, oh, sorry about that. The human body is a pretty good absorber of energy at 50 megahertz, the 6 meter band. So the exposure limits are at their lowest value there. Okay. So moving on to tonight's topic. There's two common ways to communicate on the VHF-UH bands. The simplest is to use what's known as simplex frequency, and that's also known as a direct contact. And simplex is defined that as an amateur station that is transmitting and receiving on the same frequency. That's right out of the question pool there. This is, like I said, this is also known as working direct. One of the drawbacks is the range of simplex communications is somewhat limited. It depends, 1 to 2 miles maybe, depending on power levels and terrain. Mobile to mobile or mobile to base, you might bump that up to 5 to 25 miles or more, again, depending on power and antennas, but still certainly somewhat limited. But the FCC allows the use of booster or repeater stations. Repeaters are a special station that can extend range. And they listen on one frequency, transmit on another, and that's known as duplex operation as opposed to simplex. In the little graphic here, the guy here with his little handheld radio is listening on the input to his radio is 146.76 megahertz. When he transmits on a different frequency, 146.16 megahertz. The repeater listens to what he's transmitting on 146.16 and retransmits on its output on 146.76. So the guy on the other side of the hill can hear him, extending the range. So all repeaters are going to have some kind of squelch circuit. What's the purpose of a squelch? Well, a squelch function is to mute the receiver audio when a signal is not present. That's a question pool answer. What does that mean? That means if there's nothing but noise, the receiver doesn't pass it on and nothing comes through. It's silent. With a repeater, you may use a carrier squelch. And if carrier squelch is used, the receiver audio is muted until any RF signal is present on the input. So if the receiver detects a signal and it opens a squelch, whatever it's hearing gets retransmitted on the output frequency of the repeater. Some other systems may require a subaudible tone transmitted along with normal voice audio. That's known as CTCSS or PL. So tone squelch, your transmitter has to be set up to not only transmit your voice, but a subaudible tone at the same time. So if you're going to operate a repeater, you're going to need to know some basic information. First and foremost, is it open to all users? For the most part, repeaters are usually supported by clubs or organizations, sometimes just an individual. But if somebody's supporting it, sometimes to defray the cost of operations, they might require you be a member or join some group to be able to use a repeater. Most are open to all users, but you need to know that. And it's if they are open to all users, known as an open repeater. The next thing you need to know is the repeater's transmit frequency. That's the frequency that your radio is listening on. And you'll need to know the repeater's receive frequency. That's the frequency that you transmit on and the repeater hears you on. That difference is known as the repeater offset. That repeater offset may be either above or below the transmit frequency. So it can be a plus or minus offset. You also need to know, is the repeater, does it use a carrier squelch or a tone squelch? Are you going to have to put in some kind of CTCSS code or tone to access the repeater? So you need to know that. Where do you find this information? Sounds like a boatload of information you need to know. Well, fortunately, there are repeater directories or numerous online listings where you can look up repeaters in your area, find out their location and all of the above information, the frequencies, the offset, and tones, if any, required. If for some reason you can hear a repeater, but you are unable to access it, you might be using an improper transceiver offset, the wrong CTCSS tone or PL tone, or an improper DCS access code. Those are the answers out of the question pool. So if you're unable to access a repeater and you can hear it, you might be using an improper offset, wrong tone or wrong code. Speaking of offsets, there's only 2 questions on the test that actually ask you about it, but here are 3 pieces of information. The 2 meter band, 146 megahertz, the standard offset is either plus or minus 600 kilohertz. So there'll be 600 kilohertz difference between the transmit and receive frequencies. The 1.25 meter band, 220 band, that jumps up to 1.6 megahertz. And when you get up to the 70 centimeter band, this is the other one that's on the test, which is 450 megahertz. The standard offset is 5 megahertz. 5 megahertz between the transmit and receive frequency is quite a bit. It makes it a lot easier for the repeater to function. Why, you might ask, is there such broader offset on that band? Well, part of the reason is the 2 meter band runs from 144 to 148 megahertz. It's only 4 megahertz wide. The 70 centimeter band runs from 420 to 440 or 450 megahertz. So it's a whole 30 megahertz wide. So there's plenty of room. So broader offsets, 5 megahertz on the 70 centimeter or 450 megahertz band. So band plans. This is an interesting concept. Standard repeater offsets that we just talked about are part of the VHF, UHF band plans. And what are band plans? Well, beyond the basic privileges established by the FCC, they're a voluntary guideline for using different modes or activities within an amateur band. That's out of the questions. Band plans are typically, they're established by HAMS. The FCC has nothing to do with it. They're more or less a gentleman's agreement. And they often include suggested calling frequencies, designated simplex channels, and the like as part of the band plan. For example, one of the questions is 146.520 megahertz. That's also the national FM calling frequency on the 2-meter band. So that's an example of a calling frequency specified in a band plan. So a couple of hints on repeaters when you do start to use them. Repeaters is a shared resource, so there needs to be some common sense rules. They're not too complicated. Nobody likes a windbag, so keep your transmissions fairly short and make sure that you include breaks in between your transmission and the person that you're talking to. That gives somebody else who wants to join the conversation or might have some important information to pass along a chance to join the conversation. So don't talk too long. Make sure you include breaks in between. During busy times, avoid unnecessary traffic. Not so much of a factor around here, but you get in urban areas during rush hour. A lot of hams use the repeaters for information on traffic and road conditions. So if it's busy, try to keep the chatter at a minimum. Another good thing to do is to switch to a simplex frequency if you can. If you don't need to use a repeater to talk to the person you want to talk with, switch if it's feasible. And this is one of the reasons simplex channels are designated in the band plans, is that so stations can communicate without tying up a repeater. That is a question pool answer right there. So how do you know if it's feasible? Well, one of the ways that you can, if you're talking to someone on a repeater, determine whether you can talk to them on simplex is while they're talking, you listen on the input of the repeater. You're listening on the same frequency that the repeater does. If you can hear them, then you can probably work direct, and that's using the reverse function in a transceiver. Again, question, pool, answer. Okay, now we're going to move on to something that's really neat, and that's the fact that although quite a few repeaters are standalone, they can be linked to one another, creating a linked repeater network. In a network of repeaters in which signals received by one repeater is transmitted on all the receivers, all the repeaters in the network, that's known as a linked repeater network. Several ways you can tie those repeaters together. It can be another radio link. It might be a dedicated wire line, even the internet. And as I said, signal in a linked repeater network, a signal received by one of the repeaters is transmitted by all of them. And we're really blessed in Mendocino County to have an excellent linked repeater network, commonly referred to as countywide. There are 5 repeaters located near Laytonville, Willits, Hopland, Fish Rock Road, and Upper Lake. They're tied together using UHF links. And this system allows someone who maybe in Laytonville to talk to someone on the South Coast or really just about anywhere else in the county. The Fort Bragg Mendocino area is also fortunate to have a pair of linked repeaters that enhance the North Coast amateur communications as well. So IRLP, Internet Radio Linking Project or Protocol, that's when the repeaters are linked by the internet. We talked about this last week. They use voice over IP protocol or VoIP to do that. And one of the neat things with IRLP is you can send command codes to an IRL repeater to ask it to do something, switch to a different node to make changes in the way it's operating. Those command codes to IRL repeaters are sent by DTMF tone. DTMF is the generic term for touch tones. What does that mean? Well, The DT means dual, is for dual tone. MF is multi-frequency. So DTMF is dual tone, multi-frequency. That means you're signaling with with pairs of audio tones. So the question is about DTMF signaling, and it's signaling with pairs of audio tones. You'll use that to control or send commands to an IRL repeater. And quite often, you'll notice a handheld radio or hand microphone often has a keypad on the front of it. And that's why you can use that to control the radio or to send commands. So most FM frequency modulated repeaters are analog, and that's where the carrier frequency is modulated or changed in direct response to the audio waveform of your voice. But there is an increasing number of digital repeaters on the air. And these digital voice mode repeaters take that voice information, convert it to data, and then it's transmitted that way. And if you hear a digital transmission on an analog receiver, it's going to sound like a burst of static or noise. It's not going to sound like a voice. So digital mobile radio, that is a form of digital radio. And we talked about this briefly last week. The neat thing about it is the DMR, you can set up a talk group, and that allows users to share a channel, but not be heard by others. So that's why one of the advantages of DMR, it's a narrower bandwidth, and you can set up basically private chat channels. So how do you join talk group, a DMR talk group? To join a digital repeaters talk group, you simply program your radio with the group's ID or code. So program the radio with group ID or code to join a talk group. And another thing that is used to control access or prevent interference is sometimes a color code is used. And if a color code is used, it must match the repeater color code for access on some DMR repeaters. So group ID code for talk groups, sometimes a color code is needed to access a digital repeater. Okay, a couple other quick reminders about repeaters. One is, we talked about this a few weeks ago. The use of a dummy load or a dummy antenna is recommended when making transmitter adjustments, but there may be times that on-the-air test transmissions are needed, and all over-the-air transmissions, even test transmissions, must be identified. So on-the-air test transmissions must be identified by the transmitting station. That's out of the question pool. What that means, so even if you just key up you press a button on the microphone on your 2-meter radio to see if you can access a repeater, you need to identify that transmission with your call sign. And there'll be a whole lot more next week on call signs and identification and all the rules that you need to follow. One of the problems that you may encounter on a repeater, we touched on some of these last week as well, was over deviation. And over deviation is causes your transmission into a repeater to be distorted on voice peaks. And that's kind of a signal right there. If it's distorted on voice peaks, it's over deviating. It's too much change in the frequency, and that causes your voice to be distorted and or cut out sometimes. So how do you fix this? Well, it's an indication you're talking too loudly. So if you get a report of that, speak more softly or back off the microphone, or if your radio has a microphone gain control, back off on that. But over deviation indicates you're talking too loudly, and it can cause your signal to distort on the voice peaks. Okay, let's run through quick questions through the section we just went through. What's a common repeater frequency offset on the 70 centimeter band? 70 centimeters is the 450 megahertz band, and it has a whopping plus or minus 5 megahertz offset for 70 centimeter repeaters. What term describes an amateur station that is transmitting and receiving on the same frequency? Well, that's about as simple as it gets, folks. If you're using one frequency, that's known as simplex operation. If you're transmitting on one and listening on another, that's where duplex comes into play. So, which of the following could be a reason you're unable to access a repeater whose output that you can hear? So you can hear the repeater there, you can hear it coming up, but you can't seem to bring it up. You can't open it or get into it or talk on it. So what could be a reason for that? Is it the improper transceiver offset, or that you're using the wrong CTC-SS code, or you're using tone, or they're using the wrong DCS, a digital code? Well, any of those three could cause you to not be able to access the repeater. So all of those choices are correct. The offset could be lack of a tone or the wrong code if a code is required. Which term describes the use of a sub-audible tone transmitted along with normal voice audio to open the squelch of a receiver? Well, that's that fancy 5-letter one, CTCSS. That is sub-audible tone access, CTCSS. How do you join a digital repeaters talk group? Well, you don't register with the FCC office. I'll guarantee you. You don't have to join the repeaters owners club. All you need to do is program your radio with the group's ID or code, and that information should be readily available. So let's move on. We've talked about kind of some of the ins and outs of using FM and repeaters. What about actually making a contact? You're actually going to get on the air and talk to somebody. How does that happen? What are the first steps? Well, first of all, we're going to talk about it. You're going to notice that there's some differences between the way things are done on the HF bands and the VHF, UHF bands. Doesn't matter where you are, though. The very first step before trying to make a contact is to listen. Listen for a good 15, 30 seconds to make sure that you're not interrupting a conversation that's already in progress. Remember, nobody has a specific right or a special claim to a frequency. If two amateurs want to use the same frequency, both have equal rights to it. If two stations transmitting on the same frequency interfere with each other, the two stations should negotiate continued use of the frequency. That is what they tell you in the question pool. If you're two stations trying to use the same frequency, they're interfering, it's up to them to decide who gets to use it and who moves on. Obviously, in the event of emergency traffic, things like that should have priority over just casual conversation. Before you transmit, before you start transmitting, you want to do several things. Like I said, you listen, make sure you're not interrupting a conversation in process. If you don't hear anything, the polite thing to do is come on and ask, is this frequency in use? And then sign your call. If nobody responds, and that's a good sign. But above all, make sure the frequency that you're transmitting on is within your band limits. As a technician class licensee, you can't transmit on any frequency, just any frequency. There are limitations to what you have access to. So before transmitting, listen, ask if the frequency is in use, and make sure you're within your band limits right out of the question pool. So on the HF bands, I mentioned things are a little different on HF versus VHF, UHF. On HF bands, there's a procedural signal known as CQ, and if you think about it, it could be SEEKYOU, seek you. I'm CQing you. I'm looking for you. It's an invitation. CQ is an invitation for any station to respond. So, way of saying calling any station. As I mentioned before, you start calling CQ, make sure you've listened and nobody else is using the frequency. So, say you hear someone on HF calling CQ, and you'd like to respond. How do you do that? Well, you respond to a CQ by transmitting the other station's call sign first, followed by yours. So if I heard Mike, KC6MGM, calling CQ, 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 this is KC6MGM, listening, and I wanted to respond, I would say KC6MGM, this is WB9NJS. So you call the station that's calling CQ, you give their call, and then you give yours. That's how you respond. Okay, repeaters, different story. Really different story. CQ is not used on repeaters. You will not hear that call. You'll hear it on some in VHF, UHF, maybe on the weak signal areas, but not FM and repeaters. So if you hear someone on a repeater, a station that gives their call sign followed by the word monitoring indicates that the station is listening on a repeater and looking for a contact. So if you hear someone say WB9NJS monitoring countywide, that's an indication that I'm listening on that repeater and looking for a contact. So how do you contact someone with a known call on a repeater? You don't know if they're around, but you want to see if they are. Well, you transmit their call first, followed by yours. So again, if I'm looking for Mike, KC6MGM, KC6MGM, are you around on countywide, Mike? This is WB9NJS. That's the way I would call Mike. Looking for Mike. Transfer the other station's call first, followed by yours. Okay, another quick shortcut here. In addition to CQ, which is considered a procedural signal or prosign, there are some other procedural signals commonly used by amateur operators. These include a whole series of three-letter abbreviations that start with the letter Q. Most of these were developed for CW as an abbreviation, a quick way to shorthand for CW. Two that are on the test. QRM, QR Mike, QR Mary. That is an indication that you are receiving interference from other stations. That's the wording in the question. In the correct answer, QRM, receiving interference from other stations. The other Q signal that might appear on the exam, QSY, changing frequency. I'm going to QSY to countywide, WB9NJS, telling folks I'm changing frequency. QRM, QSY, only two that are on the test, although there's a whole list of them. Okay, pop into some questions here. Let's see how much of that sunk in. Which of the following applies when two stations transmitting on the same frequency interfere with each other? Well, stations should negotiate continued use. They should choose another frequency to avoid conflict. Interference is inevitable, so no action is required. I don't like that defeatist attitude. Use subaudible tones so both stations can share the frequency. Unfortunately, that doesn't work. So the only correct answer is the station should negotiate continued use of the frequency. Be courteous. It's a shared resource. Nobody owns a frequency. So if you're on top of someone, figure out a way to work it out. Which of the following is required when making on-the-air test transmissions? Now you don't notify the FCC and there's no time limits. You simply need to make sure that you identify the transmitting station. So if you make a test transmission that goes out over the air, not into a dummy load, but actually transmitted over the air, you need to identify with your call sign. So how is a VHF, UHF transceiver's reverse function used? How might you use that? reduce the power input, to increase the power output, to listen on a repeater's input, or listen on a repeater's output. Well, normally the transceiver is going to listen on a repeater's output, so that one's out. It has nothing to do with reducing or increasing the power out. It's the reverse function allows you to listen on a repeater's input frequency. That's a way you might be able to determine if you can move your conversation with someone from a repeater to a simplex channel. So what's an appropriate way to call another station on a repeater? If you know the other station's call sign, say break, break, and then the station's call sign, say the station's call sign, then identify with yours. Say CQ 3 times and the other station's call sign, or wait for the station to call CQ and then answer it. Well, we said you don't use CQ on repeaters, so that knocks out two of them. Never said break, break. The correct answer is say the station's call sign, then identify with yours. The term break should be used cautiously. That's usually only used when you urgently need to join a conversation. Otherwise, you might say comment or just insert your call sign to join. Which Q signal indicates you're receiving interference from other stations? Well, that's the top of the list, QRM, man-made interference from other stations. Okay, moving on into the last segment here, and that's emergency communications. And proper handling of emergency communications is vital. But remember that in the event of any emergency, the FCC rules always must be followed. There is no exception. FCC rules always apply to the operation of an amateur station. However, an operator may operate beyond their privileges only if there is immediate danger to life or property. Let me get that right out of it. Yeah, only in situations involving immediate safety of human life or the protection of property. So that means you as a technician class licensee could, under the correct circumstances, actually get on a frequency that you're not normally authorized to do and transmit. But there darn well better be a situation involving immediate safety to human life or property. So emergency communications, there are thousands of amateur organizations that support emergency communications in the nation. The Mendocino County Auxiliary Communication, or Mendocino Auxiliary Communication Service, or MAX, one of the sponsors, is being one of them in Mendocino County. We're going to talk about two national organizations which may provide communication services during emergencies. First of which is known as Radio Amateur Civil Emergency Service, or RACES. Radio Amateur Civil Emergency Services. Remember that civil, because this is the definition that comes up in the questions. Radio Amateur Civil Emergency, or abbreviated RACES in the question, is an FCC Part 97 amateur radio service for civil defense communications during national emergencies. So Civil Emergency Service is the one that is the civil defense organization. The other one is the Amateur Radio Emergency Service, or ARES, ARES. ARES is a little less formal, and it's defined as consisting of a group of licensed amateur operators who voluntarily registered their qualifications and equipment for communication duty in public service. In other words, you put your name on a list and said, hey, I'm here, I've got a license, I've got this equipment, I'm available. So the definition of either one of those might appear on your test. Remember, RACES, which is civil emergency, is the civil defense one. Okay, emergency communications are typically handled in what's called a net operations. And the net is under the control of a net control station, or NCS, that the net control station directs the communication. And the typical duties of a net control station are to call the net to order and direct communications between stations checking in. That's the answer in the question pool. So net control station's duty, they direct communications, they call a net to order and they direct the communications. Good practices to follow when you are on a net. The good standard practice is to transmit only when you've been directed to do so by the net control station, unless, of course, you have an emergency situation to report. So good practice out of the questions on the pool to transmit only, unless you're reporting an emergency, transmit only when you've been asked to do so by net control. If you have urgent traffic and you're trying to get through to net control to pass that, typically you'll begin your transmission with priority or emergency followed by your call to let net control you have emergency traffic for them. And traffic, well, in net operations, messages exchanged by net stations is known as traffic. That's right out of the question too. Messages exchanged in net operation, messages exchanged by net station is known as traffic. A characteristic of good traffic handling procedure is passing messages exactly as they are received. You do no interpretation or anything of it. You take the message that you received and pass it on exactly as you got it. If there's any questions, be sure you get clarification before you do transmit a message. And so you don't potentially transmit incorrect information. Formal traffic uses some specific protocols to help increase accuracy. And one of those is a preamble. And the preamble in a formal message, it contains information needed to track the message. So the preamble contains tracking information. Another thing that's used is when a radiogram, which is a message format, is used, the check that's in a radiogram header, that indicates the number of words or word equivalent in the text portion of the message. This can be catch errors real quick. If you're passing a message and you left out the word not when it should have been in the instructions, you change the entire meaning. So if you have a count, hey, there should be 10 words or word equivalents in this message, and the person receiving it only has 9, they're going to know something's wrong and look to get that corrected. So the check in a radiogram header is the number of words or word equivalents in the body of the text. Sometimes when you're passing traffic, you might have to spell words using a standard phonetic alphabet. You'll do that to ensure that voice messages containing unusual words are correctly received. So spell words using standard phonetics. Now, law enforcement, military use slightly different ones. What amateurs typically use is an internationally recognized phonetic alphabet shown here. So in order to spell my name phonetically, if I'm talking to someone on HF, I'd say the name here is Tim Tango India Mike, Tim. So that is the International Phonetic Alphabet, using those letters, those words to represent those letters can also help clarify your call sign. Okay, so we never know when an emergency is going to strike. That's part of the nature of them. So it's best to be prepared for emergencies. And what are some of the ways you as a ham might do that? Have spare charged up batteries for your handheld radio. If your primary radio is a handheld handy-talkie, make sure you have spare batteries for them and that are charged up so you can swap them out when you run one down. Another great option is to see if you can purchase a AA cell holder for your handheld that'll fit your handheld radio. These are awesome because it allows you to use standard AA alkaline cells and pop them in. And AA's are, especially in the world of emergency response, are nearly ubiquitous. Almost everybody has a stock of AA cells, so they're readily accessible. And the other thing with the AA cells is they tend to last, alkaline will last 2 to 3 times longer than the rechargeable pack. Another good idea is to keep a 12-volt rechargeable battery as part of your station as a good power backup, since most of our equipment runs off 12 volts. One of the things that you might also be able to do with that is that the 12-volt battery is possible to recharge it in many instances by connecting it to a running vehicle and charging it off the vehicle's charging system or photovoltaic or solar cells. And this is just a quick picture. This is what I use for my backup power for my ham station. It's a jump starter with a big battery in it. I have it wired up so I can plug my radio into it, and the battery in there that will run my 2-meter radio for quite a few hours, depending on how much I talk and what the transmit power is. But always good to be prepared. Make sure you have a backup power source, all the cables that you need, so you can use your radio when you need it the most. Okay, into the home stretch here, folks. We'll see what you retain from the last segment. So which of the following is a characteristic of good emergency traffic handling? What's a good way to do it? Passing the messages exactly as received, making decisions as to whether messages are worthy of relay or delivery, ensuring that any newsworthy messages are relayed to the news media. Well, those last two don't make any sense. All of the above can't be right. No, it's important. Your job is to simply pass the information exactly as received. So that is a characteristic of good emergency traffic handling. What's a standard practice when you participate in a net? When first responding, the net control station, transmit your sign, name, and address. I don't think so. Record the time of each of your transmissions. Well, you don't have to. That might not be a bad idea, but generally, unless you're reporting an emergency, transmit only when you've been directed to do so by net control. So kind of sit back and wait to be spoken to. So the correct answer, yes, C. Unless reporting an emergency, you transmit only when you're directed by net control. What is RACES? RACES, well, that's civil emergency is the CE, and it has nothing to do with combining amateur radio and citizen band. It's not an international radio experimentation society, nor is it a radio contest. RACES is, by definition, an FCC Part 97 amateur radio service for civil defense communications. Civil emergency, civil defense, that's how you remember those two. What is meant by the term check in a radiogram header? Well, is it the number of words or word equivalents? Is it the call sign of the originating station? A list of stations who have relayed the message, box on the message form that tells you the message was received or relayed? Nope, the check is part of the attempts to minimize errors, and the check is a count of the number of words or word equivalent in the text portion of the message. That's the check in a radiogram header. Our amateur amateur station control operators ever permitted to operate outside the frequency privileges of their license class? Flat out no. Yes, but only if it's part of a FEMA emergency plan. Yes, but only when part of a RACES emergency plan. Or yes, but only in situations involving the immediate safety of human life or protection of property. So yeah, you can do it, but somebody's skin's got to be on the line or their property. So yeah, don't take it lightly, but if you need to, you can, but only immediate safety to human life. Oh, here's the other group. What is the amateur radio emergency service? Is it a group of licensed operators voluntarily registered, a group of licensed operators who are members of the military, a training program that provides licensing courses, or a training program to that certifies operators for membership in the Radio Amateur Civil Emergency Service? No, it's a group of licensed amateurs who have voluntarily registered qualifications and equipment. That's ARIES, again, a little less formal than RACES.
My name is Michael Carroll, KM60TE. I'm doing the amateur practices sub-element T4 for the class. This is a little bit of a catch-all section. There'll be a lot of things that repeat or double or cover things that we've covered elsewhere, but from a different point of view. So, and there are only 2 questions on the test out of this section, although there are 24 in the pool. So we'll go over all 24 questions and answers so that you're prepared for the test. So just to get started, your radio station will look something like this. It'll have a radio, either a mobile transceiver or a fixed base transceiver, and it'll have specifications which you will need to pay attention to because for a couple of reasons that I'm about to go into. So, coming into the unit, we have power, and you can have a 12-volt vehicle adapter. You can have vehicle power off of a battery, or you can have a DC power supply. This is a 12-volt power supply that runs off 120 volts. Most people that have a base station use a 120-volt power supply that converts 120 volts AC to 12 volts DC. So, and just to review, your mobile unit will run off of 12 volts out of your car, but also your base station will run off of 12 volts. So you could power your base station from a 12-volt power supply, but also from a battery. And many people have a 12-volt power supply and then have a battery as a backup. Tim was just talking about that. And another thing to pay attention to is the amount of power, current, and voltage required. So it's possible that your mobile unit could be powered by your cigarette adapter, and maybe not. You need to pay attention to how much power and how much current the mobile unit requires before you try to power it from your cigarette lighter, for example. So, and one of the test questions we'll talk about in a minute, we'll talk about how much power you need to power your radio. So that's the DC side, and everything here is 12 volts. Okay. On this side, this is the RF radio frequency, the RF output, and you can go to various kinds of antennas. You could have a beam antenna, a Yagi. You could have a mobile antenna on your car. You could have a fixed base antenna. And again, there are specifications for these things. Every one of these antennas is rated for a certain frequency or range of frequencies, and they're also rated for a certain amount of power. And so, for example, if your base unit only puts out 100 watts, you can use most antennas with it. But if you're putting out 1,000 watts, certain antennas you can't use them. You have to match the RF power of the base unit to the antenna, or the frequency of the base unit to the antenna. So, and there will be questions that we'll cover in a second about that. So, where should an RF power meter be installed? RF power meter. So that's on the transmitter, the output side of your transceiver. So in the feed line between the transmitter and the antenna is the first choice. The power supply output, in parallel with the push to talk line, which doesn't make any sense, or in a power supply cable as close as possible to the radio. Neither of those last 2 make any sense. Neither of the last 3 make any sense. The correct answer is in the feed line between the transmitter and the antenna. The transmitter and the antenna are the only answers here that have anything to do with RF power. Which of the following should be considered in selecting an accessory SWR meter? In one of the previous, I think when one of the other instructors was talking, we talked about SWR means standing wave ratio. That's the quality or the reflected power of the transmitted power to the antenna. In other words, matching the antenna to your transmitter. It's really important, and you don't want to have a high SWR. And so an SWR meter goes between the transmitter and the antenna. So the thing you need to pay attention to, the choices are frequency and power level at which the measurement is made, the distance the meter is from the antenna, the type of modulation being used for the station, or all these choices are correct. Well, it's not the type of modulation, so all these choices are correct, can't be right. The distance, the real issue is the frequency and power level. You can get an SWR meter for various frequencies and various power levels. So your power supply unit, we saw on that earlier diagram, let's see if we can go back to that diagram. So your power supply unit is over here. So you can either have an AC powered supply that provides 12 volts, or a 12 volt battery, or your car. So the things you need to pay attention to are the minimum current requirement. And so when you get a radio, it will say in the specs how much current is required or how much power is required as the source of power. And so the things to take into account are the efficiency of the transmitter at full power. In other words, you'll draw the most current from the power supply when you're operating the transmitter at full power. The receiver and control circuit power, and the power supply regulation and heat dissipation. So there are two kinds of power supplies. One is called a switching power supply, and the other is a linear power supply. A switching power supply is much smaller. They're usually less expensive, but they use a smaller transformer by switching the signal as a way of converting it from AC to DC, which has the advantage of being smaller and lighter and less heat, but could create radio frequency interference, RFI interference. A linear power supply is larger and heavier, but warmer, and tends to be quiet in terms of RFI. So there's a trade-off. What I do is I look around to other hams or dealers who understand what's going on and ask them what works. Switching power supplies these days tend to be pretty good, but I would avoid the cheapest switching power supply you can find, because that's where you're going to have a problem. So, and then in terms of connecting your power supply, use the heaviest gauge wire that you can. You don't want voltage drop. And the ground strap, you have to make sure you have the best ground you can get. A flat strap actually works better in terms of reducing RF. So next question is, which of the following is an appropriate power supply for rating 50 watt output mobile transceiver? So if it's mobile, well, first of all, we said all the transceivers are going to be 12 volts. So 24 volts and 24 volts, A and C it can't be right. And so, and you'll find that when you look at the specs, the range is from like 11.9 to 14 or some range like that. So 13.8 is basically a 12 volt supply. So 13.8 at 4 amps or 13.8 at 12 amps. Well, if you multiply this out, this 13.8 times 4 amps is very close to the 50 watts. You'll find that you're nowhere near a comfortable margin for current supply or power supply for your transceiver. So the correct answer should be D. And this is where, remember I said in an earlier thing, paying attention to the power calculation, the volts times amps is power calculation, it will come up over and over again. How can you determine the length of time that equipment can be powered from a battery? So divide the watt hour rating of the battery by the peak power consumption of the equipment, divide the battery amp hour rating by the average current draw by the equipment, multiply the watts per hour consumed by the equipment the battery rating and multiply the square of the current rating of the battery by the input resistance of the equipment. Well, the correct answer is B. It's the average current, because you'll find that most of the time the radio is just sitting there receiving and it uses very little current. It's only when you're transmitting that you use the maximum current. So you have to be rated for the maximum current, but your amp hour rating, the amount of time that the battery is going to last, is going to be your average current. So the key here is average. And so the correct answer should be B. Okay. Why are short, heavy wires used for transceiver's DC power connection? To minimize the voltage drop when transmitting, to provide a good counterpoise for the antenna, to avoid RF interference, or all of these choices are correct. Well, the most current you're going to draw is when you're transmitting, and so the largest voltage drop is going to be when you're transmitting. So the correct answer should be A. C and D make no B, C, and D make no sense. So the correct answer should be A. Which of the following conductors are preferred for bonding for RF? A copper braid removed from a coaxial cable, steel wire, twisted pair cable, or a flat copper strap? Well, copper is always better than steel. Twisted pair is usually very small conductors. A flat copper strap is the answer. Where should the negative power return of a mobile transceiver be connected on the vehicle? This is important. This is a practical thing that will make a big difference, and some people get this wrong. At the 12-volt battery chassis ground, at the antenna mount, to any metal part of the vehicle, or through the transceiver's mounting bracket. It turns out that any resistance along the return line of the DC will cause problems with your radio, including interference and all kinds of problems. So your right answer is to get it as close to the battery as you can. To the 12-volt battery chassis ground is the correct answer. What is an electronic keyer? This is from an earlier section, but a device for switching antennas, a device for voice-activated switching to receive to transmit, a device that assists manual sending of Morse code, or an interlock to prevent unauthorized use of the radio. An electronic keyer is used for Morse code. The answer is C. Okay, so digital operations. Why would you want to have digital operations? Well, it turns out that there are a number of programs available that are very useful or interesting, or in fact, very helpful in an emergency. So for example, there's a program called WinLink, where if you hook your computer up to your ham radio, you can send email to non-hams. You can send email to anybody with an email account, even if your internet is down and your power is down, if you have a battery backup. So in an emergency like we have here on the coast, or often in Mendocino County, where the power is out and the internet is out, you can send email to your relatives all over the country saying everything's okay or giving status without having, as long as you have a battery backup and a computer. So the way that works is that they're basically the computer and the radio. This is a little bit of a complicated diagram, but the computer and the radio communicate via audio. And the way they do that is either using an audio interface, which is this, or a computer interface that translates the audio using USB, or, and is often the case these days, an awful lot of radios have what's called an internal sound card. With an internal sound card, the radio can be connected directly via USB to the computer. So, even though this is something you probably won't do when you first get your license, it's something to really understand how to do, because for emergencies, having WinLink or being able to use WSJTX what is it? FLDigi that Tim just talked about lets you send forms in an emergency. So all of those things you can use if you hook up your computer to your radio. So this a little bit more simplified diagram is here's a Yaesu connected to, and this is a Yaesu that doesn't have an internal sound card. There's a box called a sound link or a signal link that connects. You connect a USB to your computer and then connects the signal link to your radio, and now you've connected your radio to the computer. Again, that's called a signal link. Okay, so what signals are used in a computer radio interface for digital mode operation? Receive and transmit mode status and location, antenna and RF power, receive audio and transmit audio, and transmitter keying, or NEMA GPS location and DC power. Well, the only one here that talks about audio is C, which is that's how it's connected. It's a sound card. It only does it through audio, and that's that's the only answer that talks about audio. So C is the correct answer. How are transceiver audio signals, audio input and output connected to the station configured to operate FT8? Well, I'm not sure we talked about FT8, but again, the only one of these questions that talks about, the only one of the answers that talks about audio is B, and WSJTX is the software that runs FT8, and so B should be the answer. Okay. Which of the following connections is made between the computer transceiver to use computer software and operating digital modes? Line out to transceiver push to talk. Well, we didn't talk about push to talk. Line in to transceiver push to talk. We didn't talk about that. Line in to the transceiver speaker. So the transceiver speaker is the audio out. The computer line in is the audio in. So it's got to be C. It doesn't make any sense that the computer line out and the transceiver line out would be connected. So the answer should be C. And again, the thing to remember about this connections is it's all done with audio. So the only two that have to do with audio here are the C and D, and C is the only one that makes sense. Okay, there's a thing called Tim talked briefly about digital modes. And the very cool thing about digital modes is that not just handheld, but base station transceivers can have a digital mode. And the good news is that digital modes have really clear connections. The disadvantage is there are at least three different standards. D-Star is ICOM standard, DMR is a more general standard, and System Fusion is the Yaesu standard, and they don't communicate with each other, which is very frustrating. But there is Tim talked about how your HT communicates to other radios via a repeater, and that's also true of digital modes where the repeater has a digital mode. But if you live in an area that doesn't have access to a digital mode repeater, you can install what's called a digital hotspot or a hotspot. And a hotspot is a little box. They're not very expensive, and they connect your computer to the internet so that you can use a handheld or even a base station and communicate over the digital modes, D-Star, DMR, System Fusion, via that hotspot. So hotspot is for connecting your digital mode transceiver to the internet. So what is the function performed by a transceiver and a digital mode hotspot? Communicating digital voice or data via the internet, FT8 via AFSK, RTTY encoding, or high-speed digital communication for media scouter. Well, Scouter. The only thing here that we talked about was digital voice or data via the internet. So the answer is A. What is the advantage of multiple? This is going back a couple of sessions, but what is the advantage of multiple receive bandwidth channels for a multi-mode transceiver? Permits monitoring of several modes at once, selecting a separate filter for each one, permits noise and interference reduction by selecting bandwidth to match the mode, increases the number of frequencies that can be stored, increases the amount of offset between receive and transmit. Well, it doesn't have anything to do with the number of frequencies in memory or the offset. We're trying to reduce noise by separating, and so the right answer is B. Okay, microphone controls. On your radio, you will have controls for gain. There will be something called a speech compressor or speech processor that will allow the microphone to allow your radio to give you a signal that's understandable at lower sound levels. If you have the gain turned, you will have a control for gain, and if you have the gain turned up too much or too much compression, you might have splatter, which will just sound like the like the word sounds. It will not sound clear on the radio. Over deviation or over modulation are also all three of these are bits of distortion if the gain is too high or the compression isn't set right. So RIT or receive incremental tuning. This is kind of down in the weeds of using your signal, especially with SSB, single sideband. But there's questions about this, so you need to learn it. RIT is a fine tuning. So if somebody's transmitting on a frequency and the frequency is just a little bit off, RIT, but your frequency is right on, RIT allows you to adjust the signal you're getting from them so that you hear it more clearly. And you don't need to change the receive frequency that you're already on. So it doesn't vary your transmitted frequency, and it lets you hear somebody who's transmitting a little bit off of the frequency that they're supposed to be on. So that's RIT. And which of the following controls could be used if the voice for single sideband returning your CQ call seems too high or too low? It's not AGC, that's gain. It's not bandwidth. It's not tone squelch. It's RIT or clarifier. We just talked about that. Receive incremental tuning, RIT, which is D. What is the effect of excessive microphone gain on SSB transmissions? Frequency instability, distorted transmitted audio, increased SWR. All these choices are correct. Well, it has nothing to do with SWR or increased stability, so it can't be all these choices. It's got to be a distorted transmitted audio. Okay, frequency and band selection. When you tune frequency on your radio, that's called the VFO, or variable frequency oscillator. That's how you change frequencies. And in the old days, there was just a knob that turned a capacitor and it would change the frequency of the radio. Now it's all done digitally, and you can either do it with the knob or with the keypad. Automatic frequency control, AFC, matches the incoming signal to the frequency that you've tuned it to. You can use what's called a scanning function, and it will scan over a whole range of frequencies to find a signal that's being used. Tim talked about CT, CSS, and DTMF encoders, and all of that can be stored in the memory. All these radios, whether it's a handheld or a base station or a mobile station, has memories for all of the bands that it will use, and even has alphanumeric labels so that you can label, that this is the Kaido repeater or the Laughlin repeater, for example, and it'll have the offsets and the frequencies and everything all stored in memory. And so what is the quick way to access favorite frequency channel on your transceiver? It has nothing to do with frequency offset. It has nothing to do with Vox. It uses the scan mode, but if we want to find our favorite frequency, we want to store it in the memory channel. So the answer should be B. Okay, what does the scanning function of an FM transceiver do? It checks income signal deviation, prevents interference, tunes through a range of frequencies to check the activity or checks for messages. Well, there are no messages in FM transceivers. It's going to tune through a range of frequencies to check for activities. Which of the following can be used to enter the transceiver's frequency? Is the keypad or the VFO knob, the CTCSS or DTMS encoder, automatic frequency control, or all of these choices? It's the keypad or the VFO knob, right? Automatic gain control, AGC, automatically limits the incoming signal, your voice. In other words, if you talk too loud, it will automatically clip off the signal so that it doesn't distort the signal that goes out. Keeps strong signals from blasting the listener. It has different time responses for different settings. So with CW, with Morse code, it has to be very fast. With SSB or AM, it's much slower. It's not used for FM because we're not doing amplitude modulation. We're doing frequency modulation. Squelch mutes the audio frequency when the signal is not present. Tim talked about that just recently. You'll find that when nothing is happening, there's a lot of noise you'll be receiving a lot of noise on your radio, and squelch adjusts the receiver so that all you hear are people that are actually transmitting as opposed to the noise that happens normally. So used primarily in FM, if you live close enough to a repeater that your signals are very good, then you adjust squelch so that there's no noise at all, and people's signal will come straight through. If in fact you're trying to do simplex from, in my case, from here to Casper, for example, there's a hill in the way and it's very hard to hear. And so I actually set the squelch to open so that I'm listening to a lot of noise, but I can also hear the weak signals. So, and this is a question that's on the test, is open squelch is for weak signals, tight squelch is for stronger signals. And the way it's normally used, if you're using a repeater and you have good strong signals, is to advance the squelch until the noise just disappears. So how is squelch adjusted so that a weak FM signal can be heard? Set the squelch threshold so the repeater audio output is on all the time. Turn the audio level up until it overcomes the squelch threshold. Turn on the anti-squelch function, or enable the squelch enhancement. I don't know what those last two are. So the answer is A, set the squelch threshold so that the repeater audio is on all the time. Filters are used to attenuate or reduce signals. A high-pass filter reduces lower frequency signals. A low-pass filter reduces higher frequency signals. A bandpass it only passes a certain range of frequencies. So, for example, if you're just listening to CW or Morse code, you only need a 500 hertz bandwidth. A notch is the ability to select a frequency that's interfering and eliminate it. And so selecting the correct filter requires understanding of the source of the interference. So this is a good example, is that if you're listening to a single sideband frequency signal here, and there's somebody else very close on also doing single sideband, and this happens all the time if you're on HF, is that you've got two signals. Maybe this guy over here doesn't know that you're trying to communicate over here. By using a bandpass filter, you can narrow this filter, means that all you will receive is this, and it eliminates the adjacent interfering signal. So that's a 2400 hertz bandpass filter for single sideband. So which of the following receiver filter bandwidths provide the best signal to noise ratio for SSB? And we just looked at that. It's 2400 hertz. Okay. What's the result of tuning an FM receiver above or below a frequency? Change in audio pitch, sideband inversion, generation of heterodyne tone or distortion of the signal's audio. Well, sideband and heterodyne are not FM functions, so it's the answer should be distortion of the audio signal. If you're not quite on frequency, you'll see hear a distorted audio signal. Okay, noise is another issue. There will be noise on the radio sometimes, and there are things called a noise blanker. It reduces signal pulses, like from a car ignition, for example, and that's called NB, noise blanker. There's noise reduction, is a digital signal processing. DSP stands for digital signal processing function that removes noise from a signal, or noise limiter just cuts it off, and that's NL. So it simply turns down the volume of the noise pulse. RF noise, RF current shield on a microphone cable RF current shield of a microphone cable distorting audio. Okay, so sometimes you're getting distortion or noise and you don't know where it's coming from. There's a thing called a ferrite choke. It's a little ring that's made out of iron, a powdered iron, and you can put that on various cables, including your audio cable. If you have high-pitched whine varying with your engine speed, this isn't a mobile. It could be that you have a bad ground, or you need a better ground, or you need to wire directly to the battery to eliminate that, because your radio is picking up high voltage signals from your ignition. So what is a DMR? Remember, digital mobile radio DMR plug contain? It's your call sign in CW for automatic identification. Well, we're not talking about CW here. Access to information for repeater talk groups, DMR repeater talk groups, a codec for digitizing audio, or a DMR software reversion. Well, the only thing that makes sense here is the access information for the repeater talk group. So DMR, digital mobile radio code plug, has the information for repeater talk groups. How is a specific group of stations selected in the digital voice transceiver? By group of stations selected. By retrieving frequencies from the transceiver memory, enables the group's CTCSS tone by entering the group's identification code, or by activating automatic identification. It's the entering the group's. So again, this is DMR, digital mobile radio, and the individual groups have identification codes, and that's how you get into that particular group. Which of the following must be programmed into D-Star transceiver before transmitting? They don't care about your output power or codec. It's your call sign, right? A is your call sign. And that's it. It's to your advantage to take advantage of all of these experienced ham radio people like Tim Hanna, for example, who have been doing this for so many years, that any question you have is not a dumb question. It's something that they had to figure out too. So don't be afraid to ask us questions before the test. The other thing I'd say is that we're getting close to the test times. And if you want to take the test, make sure that you sign up, because if you show up for the test and you haven't signed up and you don't have the FCC registration and we don't have the right test data for you, we can't take the test. So you have to sign up for the test. Please go to the McArc's website and make sure you sign up for the test.
Yeah, if you signed up, when you signed up for the course, you were given an opportunity to sign up for the test session. If you've done that and you have all of your information, including your FRN, the federal registration number, then you're good to go. I will already put you on the list and confirm you as an examinee on the date. And as for the April 15th in Ukiah. So if you already did that, that's great. If you signed up for the course, but it's skip signing up for the test session, then yeah, go to exams, EXAMAS, exams at mccarks.org. And that'll get you into the testing sign up portal. But if you did it when you registered for the course, you should be good. If I have any questions on that, I'll get in touch with you.
Well, I'll mention a couple of other things about the test. There's also one on the coast on noon on the April 8th. And you could sign up for both tests. I mean, you could take the test on the coast, and then if you didn't pass it, you could take the one inland. You can also take more than one test. If you pass the technician test and you want to take the general test, you can do that too. You just have to tell us ahead of time so we make sure we have the test information.
I just have one quick comment regarding the FRN number.
Yes.
If you haven't done that yet, if you don't have the link still, I think we sent the link out at the beginning. If you don't have it, you can just do a quick internet search. I hate to say Google search, but you can do an internet search for FCC and then FRN. I think the first link will pop you right to it. It'll go through on how to obtain your FRN, which you need in order to take the test. So the FCC has to have your information. If you start signing up for it and you realize it's a pain in the butt, you're doing it right, because it is a pain in the butt. But you're going to need your FRN number in order to take the test.
I would like to add one thing about the RACES and ARES, where you're talking about RACES. When the federal government eliminated the old Civil Defense Service, they turned that responsibility over to the State Office of Emergency Services and the County Office of Emergency Services. So when people are activated for RACES, it is only people who work directly with the Office of Emergency Services or some other federal agency, such as the military. In the event of a national emergency, if a RACES order is issued, it means no hams other than members who work directly with the Office of Emergency Services are permitted to use the radio at all, period. Only RACES personnel. In our case, it would be the MAX members who actually work with the Office of Emergency Services. For ARES, ARES is actually a sanctioned group by the Amateur Radio Relay League. So even if you want to volunteer your time and equipment, unless you can join a certified ARES group, you would not be an ARES member. Right now in Northern California, there are no ARES groups. But if you want to volunteer, you can volunteer with MAX, the Mendocino Auxiliary Communications Service, which is the amateur radio arm for the Mendocino Office of Emergency Services. And you can volunteer your time and your equipment, and we will gladly let you join the MAX group, and you can work with the Office of Emergency Services in emergencies. Now, even if you aren't a MAX member, you can actually be used for emergency operations. It's just there are sensitive areas that the Office of Emergency Services will only send the vetted MAX members, such as to hospitals and nursing homes, schools. Everyone who is a MAX member has been vetted by the Sheriff's Department with a background check and then issued an ID card that says they are actually a MAX member. So if I walk into a nursing home in Willits, saying I'm your ham radio operator, here's my ID. It says that I'm a disaster service worker for the County of Mendocino for auxiliary communications. So I just wanted to straighten that out in RACES, ARES, and MAX and what the three organizations do.